Welcome to Literacy Matters. I'm your host, Cheryl Lundy Swift. I am so thrilled to talk with Dr. Carolyn Strom, an incredibly passionate and brilliant educator. Carolyn is an early literacy expert who works with preschool and elementary educators, families, and children to improve reading outcomes. She taught first grade and was a reading specialist for 10 years in Los Angeles, Compton, and New York City. She is currently a clinical assistant professor at NYU, where she was recently awarded the Distinguished Teacher Award. Carolyn, congratulations on that award and welcome to the show.
Thank you. I'm so happy to be here.
So, Carolyn, I have about 1,000 questions for you about how the brain learns to read. I am just fascinated about the brain and how, again, all that we now know about how the brain learns to read. So it's going to be really torture for me to limit my questions to just a handful. So listeners, I really encourage you to listen to other podcasts and webinars that you see Carolyn just associated with, because it is all great. So what I'd love for you to do is, you have this way of talking about this complex research about the brain, and you make it simple and concrete. Would you mind sharing what we really need to know about how the brain learns to read, Carolyn?
Sure. And thank you. Thank you for pointing that out. When I was a teacher, I often felt that there was a lot of research out there that wasn't made accessible or actionable to me. And it's really my passion trying to just get sort of the core ideas of some of the neuroscience out there. But in terms of thinking about the brain and reading, I think the number one thing to know, and probably a lot of your listeners know, is that we're not wired for reading, right? Our brain comes set up with sort of the neurological system for speech, for spoken language, right? Yep. We've been speaking for between 50,000 to 200,000 years, and we've only been reading or writing for 5,000 years. Right. So we don't have a system that we come with, right? We don't come with a built-in system for written language. We come with a built-in system for spoken language, right? And the biggest implication of that is that speaking can be caught, whereas reading and writing really have to be taught. Right. And usually I find, when working with schools and families who are like debating, do we need explicit instruction or not? And having the old debate between explicit instruction and discovery learning. Well, if you look at the brain, you know that like we're not just going to discover and naturally come to written language, right? In the same way that we can catch kind of spoken language. So that's number one. Number one, we know we have to build an entire new system, right? Entire new circuit for reading. It's not going to happen just like the way we learn to walk or talk.
So Carolyn, I just love your imagery and alliteration around your image that you are now calling a brain city. Now, would you mind telling our listeners about Brain City? And I know that you also have an image that you'd like to share too. So go ahead and start pulling that up. For those of you who are listening, we will put this in the show notes and it will be included in our blog as well. And for those of you who are watching on YouTube, well, obviously you'll be able to see it. So Carolyn, feel free to walk us through Brain City.
Great. Thank you so much for letting me show this image. I think it's pulling up.
Yep, it's loading right now.
Okay. Can you see it?
I can see it totally great.
So yeah, this, I think it's really important to have a mental model of what we're talking about when we say, what does a child's brain do when it learns to read, or how does a human brain learn to read? And in order to have a mental model, right, it's helpful to have some visual. And so this is sort of the visual I use to explain kind of what's going on in our brain as we're learning to read. So as you can see, if you just look at this image, or if you listen to what we talked about before, right, spoken language is a really big part of reading. It's the foundation of reading, right? Reading is really built on top of spoken language because that's what we've come wired for. And so if you look at this image, right, spoken language is kind of like in the center. It's critical, right? When we think about spoken language, we think about meaning, right, and sound. Spoken language is making meaning from these sounds that come out of our mouths and turn into words. And so we tell kids that, spoken language and family, spoken language is really where reading starts. And what we mean by spoken language is this area called meaning mountains, right? We have this area of our brain that's responsible for processing meaning, right? For knowing the difference between the animal bat and the baseball bat. We have a whole area, multiple areas of our brain in charge of just making sense of things, making sense in the world. And instead of using sort of a scientific name around that, we call it meaning mountains, right? And we're doing that right since birth, we're making meaning. And spoken language also includes an area that we call sound city, right? Some people might call it the phonological processor or auditory processing. But we tell kids, there's another area of your brain that processes sounds, right? And it doesn't just think about what a bat is, but actually that it helps you hear the sounds at, right? And then produce the sounds bat. So when we think about spoken language regions, we think about how we have meaning mountains and sound city, and those kind of come together to form our spoken language regions. So if you're looking at this image, and spoken language is in green, right? And so we know that blue and yellow make green. And so any teacher out there who's concerned with color coding, I'm a big color coder, the green is intentional to remind us that sound city and meaning mountains, they come together to form our spoken language regions. They're green. And I should say, this is a cartoon version of the brain, but also in spoken language regions, we have syntax and morphology. All of that falls into the spoken language regions, right? And so when we think about reading, right, sometimes people think it's like a visual process, but actually the point here is like when we think about the reading brain, we have to think about its foundation as spoken language.
Got it.
We need to develop our spoken language because in order to read, we have to attach a new area of the brain onto spoken language. And in this model, we call it vision villages, right? So we know that we're not wired for written language, but we do have vision, right? And we're actually wired really to recognize faces and objects. Right? We recognize faces and objects really easily. We have a part of our brain in the occipital lobe in vision villages where we process faces and objects. We have this specific area for faces and objects. We do not have an area that processes symbols as sounds, right? Vision villages doesn't come with the neurons ready to process a symbol and turn it into a sound. But we need to do that, right, in order to read print. So if you're looking at this model, we say vision villages, right, is when we see words in print, initially they're processed by our vision system, vision villages. But vision villages, some of you may know it as the occipital lobe, the vision villages is simply not wired to see a symbol and convert it to a sound and then into a series of sounds to words. And so actually what we have to do in vision villages is retrain our neurons, right? Retrain these neurons to see symbols and then connect them to sound city in this model, right? To connect vision to spoken language. In order to do that, we need to take these words, compose them into their letters, and then link these individual letters into sounds. And so we call that building the neural pathway between vision villages and sound city, right? If you can't see that a little line and a circle, I'm calling a lowercase b, if you can't connect that a line and a lowercase circle connects to a b sound, right? You're not going to be able to begin to read the word bat. And so we actually have to retrain these neurons in vision villages to sort of speak to the sounds in sound city to begin to read a word. And so in this way, I used to call the model the Tale of Three Cities because in order to read, we're really connecting vision villages, sound city, and meaning mountains. We're connecting these three cities. But the more that I've spoken to teachers and sort of used it in practice, the more I've come to see that like what we're really doing is building a brain city, right? We're building this whole new city, these three neighborhoods. It's really a tale of three neighborhoods that work together to form an entire new city. Right? It's a diverse city. It's wide ranging. It's all over the brain. We connect these three hubs, right? These three neighborhoods, these three hubs to build this whole new brain city that specializes in basically converting written symbols into spoken language, into speech. That's ultimately what reading is. And so I just, as we're talking about vision villages and how we sort of specialize the neurons in vision villages for letters and to transform these letters into sounds and words, I just want to point out to what's on here, the letterbox lookout. And that is supposed to be sort of this representation of how a new neuronal cluster comes together and specializes for letters and words. And as many of you probably know, Stanislas Dehaene, the neuroscientist, has coined the letterbox for the area that others call the visual word form area. So we can either call it the visual word form area or the letterbox. And that's an area that systematically activates in anyone who really is reading effortlessly. It's the part of our brain that allows us to read words in milliseconds, right? And so the letterbox is a really key aspect of understanding the reading brain. And so in order to keep with the alliterations of this model, to keep it memorable and sticky for people, we call it letterbox lookout. And that really symbolizes this sort of neuronal cluster that develops to process words effortlessly, automatically, right?
I
And we have to, that's really a vision, something in our vision system that we have to retune, just like there's an area of our sound city we have to retune to process words as individual sounds, right? Phonemic awareness. We have to tune our brains for phonemes, and we have to tune our brains for letters and groups of letters. So that's the symbolic nature of letterbox lookout.
love that. I see that you have two other areas that have this crazy alliteration, which I think is fantastic. You were able to do this for the Brain City. Attention antenna and handwriting hub. I'd love for you to tell me a little bit more about attention antenna.
Okay. So, a lot of times when we think about the reading brain, we think about these three key areas, and those key areas are very, very important, right? Whether you call it vision villages, sound city, and meaning mountains, and with the specialized letterbox lookout, or if you call it something else. But there are these other elements that we know from research are critical to reading, right? Reading achievement. And one of them is executive function, right? Which is a part of our attention, our attentional systems. And even though attention, right, it's not domain specific to reading, right? It really applies to all learning. I think it's kind of a mistake to be separating the science of learning from the science of reading, right? Or that's like the learning brain from the reading brain, because the reading brain is a learning brain, right? The learning brain is a reading brain.
Yeah.
So that's why we put attention antenna here, to remind us always that no matter what we're learning, attention is critical, right? Attention antenna in this case is really like the spotlight, right? Attention antenna decides, what am I going to focus on, right?
Yep.
How am I going to focus? And we know that within attention antenna or attention processing, we have executive functioning. And executive function, right, we know is highly correlated with reading achievement. So we always want to be thinking, right? How are we helping students focus their attention, manage their attention, stay engaged? Because both attention and executive function correlates with working memory and reading and all of these other elements. So that's the significance of attention antenna. We can never ignore that. And one example of how to think about it is, I tell my students, like, we know from research that it's important to attend to letters, right? Not whole words.
Right. That's right.
That's attention antenna's job. Where are we calling students antennas to? Are we calling their antennas to whole words, or are we calling them to individual letters and words? And we know from decades and decades of research that calling attention to letters and words really helps them in learning to read, right? And also just overall helping them manage their cognitive resources.
Yeah. I
Also,
love that you talk about this idea of like the science of learning and how it is connected and it needs to be connected to the science of reading. I think I th- I think Zaretta Hammond talked about that at the Reading League a lot, marrying the two. They should not be separate.
yes, yes. And you know what? I'm glad you brought that up, because she also kind of gets into the limbic system, right? The role of emotion
Yeah.
and sort of identity and self-esteem.
Hmm.
And we often think of sort of the limbic system as somehow separate from the thinking system.
Right.
And that's just not the case, right? We know that the limbic system, our emotional processing system, is also actually tied to attention antenna. right? And how kids feel, whether they feel safe, whether they feel seen, is completely tied to whether they're going to pay attention or not, or whether they're going to remember or not. And the other thing I wanted to say about attention antenna is that it is involved in, especially in the early reading, it's involved in the decoding process, very much so. So when kids are converting letters that they process in Vision Villages, when they're converting them and sending them to Sound City and then sending them to Meaning Mountains, that's a very cognitively taxing process. If you've ever sat with a child as they're learning a letter pattern and then converting it to a sound and then bringing it together with another letter pattern, converting it to a sound, and then holding 3 or 4 sounds in memory and bringing them all together, that takes a lot of attention antennas resources.
Yeah.
Right. And I forgot to mention here that the purple here are the neural pathways connecting Vision Villages, Sound City, of course, because red and blue make purple. And then heading over to spoken language. That's really what scientists call, I mean, it's a cartoon version, but of the dorsal pathway, which is the slow pathway, which is the effortful pathway that all novice readers use in order to read words, right? But as time goes on and as these 3 areas fire together, right? Vision Villages and Sound City and Meaning Mountains fire together, the neurons begin to wire together. And another route forms between Vision Villages and spoken language, and I just added it on here. This orange route, scientists call it the lexical route. It's the route that processes words at like supersonic speed. So sometimes with kids we call it the supersonic highway, right? But it's the highway that has been trained over time because these neurons have fired and wired together. We developed this second pathway, the neural pathway between vision and spoken language that works in concert with the initial pathway, with the slow pathway, if that makes sense. We
Yeah.
just develop a faster connection between vision and spoken language.
When you think about what you're saying here, is that again, I love this. You keep calling it a cartoon imagery, but it's so easy for us to kind of see how it all works together and that we can, in fact, move from this, from really putting forth a lot of effort, a lot of energy
Mhm.
to it becoming, again, more instantaneous
Mhm.
with time,
And it's
practice, right?
essential because that is what we know slows down or impedes, right, comprehension.
Yeah.
So ultimately, non-automatic reading, right, non-fluent reading really impedes kids' comprehension because their attention antenna or their attentional resources are being bogged down in the multisyllabic decoding, the word-by-word decoding, right? We have to free up attention antenna to focus on meaning,
Sure.
right?
Absolutely. Absolutely. So, you have one more thing that I want to call attention to, and it reminds me of my first episode of season 3, where I had an opportunity to talk to doctors Christina Bretz and Suzanne Asherson about the power of handwriting as an integral literacy skill. Now,
Mm-hmm.
in the Brain City, you have it, outlined here as Handwriting Hub. I'd love for you to share with our listeners how and why handwriting and writing are so important to focus on when it comes to early reading.
Yeah, wow. So much to say about handwriting. So first of all, right, when we think about writing, reading and writing, they're 2 sides of the same code, right? When you're learning to read, you're learning the same code that you're then going to write. So they're really 2 sides of the same code. And we know in terms of development, they have a reciprocal relationship and a bidirectional relationship. When you work on decoding, you're helping, you're remembering these symbols. And when you're working on writing, you're also helping to remember these symbols, right? And really sort of develop this neural specialization for letters, right?
Yeah.
Which is ultimately where reading starts. And what a lot of the research has shown over the years is that when we teach kids how to form the letters and get very intentional about the gestures, right, from a very early age, and really teach them the handwriting moves, we know that they activate basically brain city, right? We know that they activate the brain network underlying reading. The more that kids engage in handwriting as opposed to typing, let's say, right, or moving letters around, the more they engage in handwriting, the more they're going to begin to activate this network that underlies reading. And if you think about it in this model, right, the more that you write letters, you write words, you're building these neural pathways between Vision Villages and Sound City.
Yeah.
right? In fact, you're building it through the whole network. So if you think of a word you want to write, right? You think of the word bat. Where does it start? It starts in your spoken language, right?
Hmm.
But in order to write bat, you have to break it down into its sounds. Bat, right? And then in order to write it, you have to think about what it looks like, right? The symbol perception. You have to have engaged symbol perception, and that's Vision Villages. But then in order to write it, you involve the motor skills, which are up by Handwriting Hub.
Sure.
So for those of you who, are curious about the official names of the brain, of the areas of the brain, like the Handwriting Hub would be in the motor cortex,
Sure.
right? We control all of our handwriting through the motor cortex. And then Exner's area is the specific area of the motor cortex that controls handwriting, right? And so when we have to think about a word to write, and then writing it, we're really engaging all of these areas, including the motor area. And we know that when we do that, we see a bigger impact on sort of the brain network beginning to form that underlies reading.
I'm so happy that you said that. What I love about it is what you have said here is that not only should you do it to help their handwriting improve, but
Mhm.
obviously you should do it because it helps their reading improve.
Exactly. And I think maybe the problem is like handwriting has a bad PR rep or something, or a bad marketing department, because it's not penmanship. Handwriting is not penmanship, right? And for a long time, people I think still maybe associate handwriting with penmanship, but handwriting it's a tool for practice, right? It's how we practice our letter sounds. It's how we practice writing words, and in practice writing words, that helps us read words because we're training the circuit into ways. That's why dictation every day is so important, right?
Wow.
Not just writing, and handwriting, but dictation. Having kids think about a word, and then have to recompose them, right, by writing them. That's huge. That just is so good for the network, right, that underlies reading.